This actually is a review slide, but I need you to remember one of the things we already learned about the periodic table. So this is just an excerpt of the periodic table. These are the group A elements. And remember, we talked about valence electrons. Their group number is the number of valence electrons that they have. And kind of related to that, actually, related to the valence electrons, is will they lose electrons or gain electrons? And now hopefully this is we're coming full circle a little bit. So we said that these metals, specifically the metals in 1A, 2A, and 3A, will lose one valence electron and form a +1 charge. 2A loses two valence electrons and forms a +2 charge. 3A loses three valence electrons and forms a +3 charge. So I could have put a +1 for this group, a +2 for this group, and a +3 for these metals anyway. So that's one of the things we talked about before. Then kind of from left to right, by the way, these 8A, you guys would probably tell me those are the rare gases or noble gases. Those are unreactive. They don't like to lose or gain. They are just happy how they are. And so then here with the halogens, 7A, there's a -1. They pick up one electron. The 6A pick up two electrons and become a -2. And these are all nonmetals. 5A nonmetals pick up three electrons and form a -3 charge, okay? So I'm hoping you all remember that. These are called, there's different types of ions, and these are called monoions. Monoatomic, one atom, monoatomic ions. All right, so if we're all on the same page there, here we go to compounds. So those ions, the metals forming cations, positively charged cations, the nonmetals forming negatively charged anions, they actually will go together to make some of these simple compounds we're going to be talking about. Remember, an ionic compound simply has one metal in there somewhere where an electron's been transferred from the metal to a nonmetal to form then an ionic bond between those two pairs of atoms. So I want to talk about compounds. It's just this word binary means that we're only going to have one type of metal and one type of nonmetal. Okay, we're just kind of keep it simple here for this short course in chemistry. Bottom line is when you write the repeating unit, that repeating unit with its positively charged cation and negatively charged anion, that repeating unit needs to be neutral. And I'll kind of talk you through what that looks like. So when you write the formula, the chemical formula like H2O for water or NaCl for salt, NaCl is a good example because NaCl is table salt, sodium chloride, and all this is saying is what we don't do is we don't write the charge up there. No, 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 no. Okay? But with that okay, that's what that's saying. NaCl is another good example of this. NaCl, even though we don't write the charge, we know that this is what's happening. So we always write the cation and then the anion. And of course the cation, especially in our examples, in all examples, this will be your metal. And in our examples, this will be your nonmetal. So that's how you write them, and actually that's how we're going to come up with their name too. Okay, there we go. To name them, for the ones we're going to be doing anyway, they have a first name and a last name. Okay, so you guys would tell me table salt is sodium chloride, and you're correct. So you just give the first name is the name of the cation, the metal, and then the last name is the name of the anion, but instead of chlorine, okay, oh goodness, chlorine. So, are you serious? There we go. Instead of the element chlorine, what we do is we lop off the end, which is INE in this case, and replace it with IDE. So you guys would tell me that that's sodium chloride. right? Okay. So actually all of the non-metals that form anions, we do this. So we lop off the tail end and we add ID as in dog, IDE, right? Okay. All right. So I've got a few examples for you here, and then I'm going to ultimately building up to you then making neutral formula units, making the writing the formula of the compound, making sure it's neutral, and naming it. So the example I have here is sodium sulfide. And these are actually what we call Lewis dot structures, where sodium, if you find it on the periodic table, is 1A. And so 1A meaning it has one valence electron, and there is the one valence electron right there. Sulfur is a 6A, so we have 2, 4, 6. Okay, 6 valence electrons around a sulfur atom. All right. So actually then, since sodium is a 1A, it forms a +1 charge, and your 6A should have a -2 over it. Okay, and so it ends up looking like this, where electrons are transferred from both of the sodiums, and those sodiums then end up being a +1 and a +1, and that sulfur, which now is going to be sulfide, IDE, it changes from sulfur to sulfide, that's why we call it sodium sulfide, is going to be a -2 anion. And here we have our two cations. Okay, all right. One more thing before I leave this example is I want to show you something that I think comes in handy called the crisscross method. So if somebody says, I want you to join, I guess it would have to be written this way, I want you to join sodium and sulfur. Okay, and we're going to make ionic compound out of those two elements. Well, hopefully we're all on the same page. We can find, you got to know the symbol for sodium is Na. When you find it on the periodic table, you'll see it's in group 1A. That means it forms a +1 charge. Then you got to remember that the symbol for sulfur is S. When you find sulfur on the periodic table, you'll see it's 6A, and hopefully you'll associate 6A with a -2 cation. So the crisscross method goes like this, where we say the number of the number of sodiums we need is actually the magnitude, let's see how I say this, the number of sodiums we need is actually the magnitude of the charge of the anion. That is a 2 there. The number of sulfurs we need is the magnitude of the charge of the sodium. So that's where the crisscross goes. So if I rewrite this, I have Na2S1. It's crisscross. So when I said it needs to be neutral, here's how the kind of testing the neutrality, the true neutralness of that formula unit goes. I have two sodiums, they're both a +1, and I have one sulfide and it's a -2. Okay, so actually if you add this together you get what? 0. So that's what we mean by neutral. So let's look at one more example. What if somebody says I'm going to mix magnesium and chlorine? So let's just, before we look at how the electrons were transferred, magnesium, you're going to find it in 2A, and so that metal forms a +2 charge. Chlorine, you're going to find that in 7A. 7A forms a -1 charge. Let's go ahead and crisscross here. So the number of magnesiums I need is actually the charge, the magnitude of the charge on the chloride ion. So I need 1. The number of chlorines I need actually is the magnitude of the charge on the cation, 2. So it goes like this, criss cross applesauce. Okay, so I hope that works. And actually, if you were to do a quick test We have 1 magnesium, it's a +2, and we have 2 chloride ions, and they are -1. So that's 0. So that's awesome. Okay, well, I guess that's all I have there, right?